This unit is about basic chemistry for biology. You might wonder why you need to know about chemistry for biology, but surprisingly, a lot of biology has to do with chemistry. And since you haven't had any chemistry so far, it's important for you to understand a few basic things about chemistry before we start getting into things that are a little bit more complicated. So we're going to spend a couple of weeks learning about basic chemistry concepts like the periodic table and balancing equations and so forth. So the first notes here are about the periodic table. As usual in biology, there are lots of words to deal with. Not all of these words are ones that you'll need to do, but these are the vocabulary terms that you need for this particular part of this lesson. This lesson is about the periodic table specifically. So pause the video, copy the vocabulary words down, make sure you get definitions as you go along. Remember, the words are going to be in italics as we go through the notes. So we're starting off with talking about the periodic table. You know what the periodic table looks like. You may not know anything about the history of it. It was organized by a Russian scientist named Dmitry Mendeleev back in 1869. And what he was doing is trying to show the trends that he saw that repeated periodically throughout the known elements. There have been modifications to the periodic table throughout the time since 1869. In its present form, it lets us look at the properties of elements and their trends. Remember, an element is a substance that is made of the same atoms throughout. Here's a picture of the periodic table. This one's color-coded, which is kind of nice to see some basic things about it. And you can see basically the way it's arranged. You have columns and rows. The columns are called groups or families. The rows are called periods. Okay? So the rows tell us how many energy levels are found in the atoms of each element. Energy levels, it has to do with the way the electrons are arranged around the nucleus of the atom. The columns are families, they're also called groups, show us the general properties of each element or each group of elements. In other words, how its atoms combine with other elements, how it reacts, and things like that. Within the column, within the family or group, there are characteristics as far as forming bonds and so forth that are common to all members of the group. So it's important for us to understand how that works. When you look at the element box, there are a couple of things you can tell about it. Of course, first of all, you see that it's got the symbol for the element and the name of it, okay, and a couple of numbers here. At the top, you have the atomic number. This tells us how many protons are found in each atom of that particular element. I chose vanadium just as an example, and you can see that its atomic number is 23, which means it has 23 protons in each atom of the element. The mass number, which is found down here at the bottom, tells us how many total protons and neutrons are found in an average atom. Now, here's the thing you need to know about the average atom. Some atoms of this element may have more neutrons or fewer neutrons than the average. But when you take the most common isotopes of the atom and average them together, this is what you get for the average mass number. So that's why it's expressed as a decimal here. If you were doing calculations with this, which you will need to do, you would round this number to the nearest whole number. So in this case, it would be 51. So if you ask me what the mass of vanadium is, I will tell you it's 51 atomic mass units. The number of electrons in a neutral atom is equal to the number of protons. Notice I said in a neutral atom. That means it's got the same number, okay? The electrons are arranged in different energy levels. Each energy level can hold a maximum number of electrons. It doesn't necessarily have to have all of those filled, okay? But it has a maximum number. The outermost one, whichever one that is, can hold a maximum of 8. Notice that there are others. The innermost one can never hold more than 2, and then the next one can hold 8. Then the next couple of ones can hold 18 unless they're the outermost one, and the outermost one can never hold more than 8 electrons. That's important to understand what we are going to talk about next. Now, the number of electrons in that outermost energy level tells us how those atoms can combine with other atoms to make compounds. All atoms would really like to have a complete outer energy level. They would like to have that outermost one filled up as full as it'll go. And they will do various things to make this happen. They will lose electrons, they will gain electrons, they will share electrons to help make this happen. It makes them more stable to have that maximum number. And so depending on where they are in the periodic table, that'll determine whether they're going to lose, gain, or share electrons to accomplish this. The number of electrons the atom usually gains or loses to get that complete outer energy level is called its valence number. That's an important term. We're going to use that for a lot of things. Now, you can figure out an element's valence number by looking at the column or family it's found in. The columns or families are numbered as they go across 1, 2, 3, 4, 5, 6, 7 to 18. And if you look at those, you can tell how many electrons it will gain or lose. If an atom loses an electron, remember electrons are negatively charged, then it's going to have a positive charge because it will then have more protons than electrons. If an element gains electrons, then it's going to have a negative charge, and that because it will have more electrons than protons, more negative charges than positive charges. So atoms in this first column here have a tendency to lose one electron in order to make compounds. That gives them a valence number of +1 or 1 plus. That means that they'll have a charge of +1. In the second column, they'll have a +2. We're going to skip over this middle part here and go over here to this column. They're going to have a +3 valence. That means they have a tendency to lose 3 electrons when they're forming compounds. The next column is kind of interesting because it's half full or half empty. You can look at it both ways. And so atoms in this family have a tendency to either gain or lose 4. If it's easier for them to, if they're making compounds with things that have a tendency to gain electrons, then they'll lose them. If they're making compounds with things that have a tendency to lose electrons, they'll gain them. Whichever way they'll go, they'll gain or lose 4 of them. Oftentimes, ones in this family will share electrons, and we'll talk more about what that means later. The next one has a tendency that this one has 5 electrons in its outermost energy level, so it's going to be easier for it to gain 3 than it is to lose 5. It's going to take less energy for that to happen. In the oxygen family, they have 6 electrons, so they have a tendency to gain 2 electrons. This halogen family, the fluorine, chlorine, bromine, and iodine, have 7 electrons. It's really easy for them to gain 1 electron and have a -1 charge. And the final column here, the final family, is called the noble gases. They do have a complete outer energy level, and so they have a valence number of 0 because they do not tend to make compounds with other elements. In the middle here, we skipped over that part. That's because these metals here have variable valence charges. Most of these have 1, 2, or even 3 different valence charges depending on how their electrons are arranged. We're not going to worry about that in biology because in biology we're going to be dealing mostly with ones over this area and a few over in this area here. So we're not going to worry about that, and we'll let your chemistry teacher take care of teaching you about how that works. Now, other things that you need to know about the periodic table. Oftentimes when you see a periodic table printed, okay, you'll notice that there's a zigzag line here along this part, okay? Elements to the left of that line are called metals. That means they have characteristics like a metal. They're shiny, they're malleable, they're ductile, they'll be drawn into wires and so forth. The ones on the right of the zigzag line are generally nonmetals. Those are things that are not metallic, things like oxygen and fluorine and so forth. The ones that are right on the line are what we call metalloids. Metalloids have some special properties that are somewhat like metals and somewhat like nonmetals, depending on lots of different things. And again, those are things we're not too worried about in biology. We'll let your chemistry teacher take care of teaching you about that in chemistry class. Just know that the metals are to the left, the nonmetals are to the right, the metalloids are right there along the zigzag line. When atoms join together with other different atoms, they form something called compounds. Generally speaking, the compounds that are formed from a metal and a nonmetal are called ionic compounds. That means they have a tendency to form ions. And we'll talk more about that in the next part of the unit. The ones that are formed from 2 or more nonmetals are called covalent compounds. They have a tendency to share electrons. And again, we'll discuss both of these and how they're formed in the next part of this unit.